So we have only very simple unit to consist of very simple topics that we will discuss today. Like the fourth unit and the fifth unit is very simple. Fifth unit consists of what is an expert system. Mostly they will ask you what are the phases in this expert system. Explain the design and architecture. Design and architecture of an expert system. And they will ask you, oh, what are the tools to build these expert systems? These three are very important because somebody wish to develop an expert system. Already we have shells that are available that you can directly use them plug and play. Like knowledge acquisition, you have a phase where you can use them. A set of tools that are already built in mostly in Fortran, some of them in C language also. That is the reason. Expert systems can also be built in C language by using C language, Fortran, something like that. So mostly the concentration will be on what, how many phases are there, and each phase, what are the functionalities of each phase, and what is the architecture of the phase. If somebody wish to design the architecture of expert system, what are the phases of this architecture, and what are the standalone tools that are available to build these expert systems. Then a simple concept called as Blackboard system as that. Like you wish to design an expert system, you need to have various people. Like people see, I wish to have an expert system in health informatics. We need to have uh, health practitioners. We need to have statisticians. We need to have this medical people. You need to also have the doctors, and many people are there. And we need to have a platform where we can sit together and work based on various constraints. We call that as Blackboard system. And truth maintenance systems. How can we take decisions, and how many types of truth maintenance systems are there? Like we have a non-monotonic system, monotonic system where one system we decide or we infer something that will be valid for the rest of the time. The other system you take some inference, it is not valid after some time. So these are the your syllabus of the fifth unit. A Blackboard system is an environment where you can design an expert system where you have set of knowledge sources based on the domain experts that they have. Truth maintenance system is how can you take some decisions without incomplete information. Something like that. So the concentration, most of them, when people try to have questions is on various phases of expert systems. How do you draw the architecture of an expert systems? What are the tools to build this in expert systems and so on so forth. And then they may ask you what is the difference between expert system and normal system. Blackboard system, you also have a rule-based system. Whenever people ask a rule-based system, you need to write about this water jug problem. The rule-based system. A lot of things are there in this particular unit, which is very simple and we can easily do that. So what is that we do is we just simply see what exactly is this phases of expert systems. Can somebody just tell me what are the phases of your software engineering process models? What will be the various phases in process models in software engineering? like waterfall model is there. What are the various phases in this waterfall model? Can somebody just tell me what are the various phases in this waterfall model that you have studied in software engineering? Is my voice is audible?
Yes, sir.
Yes, yes. Okay, when you have various process models in software engineering, what are the various phases means you collect the requirements, then analyze and design, you implement and you test the software and then you're going to maintain the software phase of that. But expert systems are something different systems compared to the in normal systems because these are not general systems. Expert systems will have a domain. Like Mycin, if you consider Mycin will be talking only about health informatics, not about any other thing. It will only process things pertaining to health informatics. When somebody wish to design an app or an application or an export systems pertaining to health informatics, so many people need to validate this whether your work is proper or not. So most of the export system will be restricted to a particular domain, and the amount of knowledge they process is immense. Knowledge they process is immense, and there will be a huge societal benefit. Whether you go for weather prediction, farmers will be waiting for the weather. You think about stock market prediction, people will be investing indirectly or directly into the stock market. You have health informatics, people are concerned about their health, and so on and so forth. So, expert system will have a different perspective, like it has its own domain of operation, it has its own way of representing knowledge, it is having own significance. And the most of the expert systems will give you some decisions and that we can call at some point of time as an expert advice, which has to be validated at some point of time. It can be true or false. If it is true, then most of the people will use this expert system for having some conclusions. So you have many law functionalities of Mycin, and almost 256 different type of functions are there for Mycin. Initially, Mycin has started very less and then started having the profilings and so on and so forth. So what are the different phases if somebody asks is like you have the first phase as identification phase. So whenever we are talking about expert systems, we'll be talking about two people. The one is domain experts, the other one is knowledge experts. Domain experts are experts in that particular field. See, I am implementing something in bioinformatics. I may not be the domain expert. I may be the knowledge expert. Knowledge expert is the expert who design the software and who try to conclude something from the data that we have. Domain expert is an expert who is working in that area. Like, see, I wish to find out what type of cancers will be there for the patients. Then the domain experts will be the doctors, practitioners, and so on and so forth. I may be implementing the project, but my role will be around knowledge experts. See, I have some knowledge, and based on that knowledge, I will just try to makes my conclusions based on the program that I write. So what does your identification phase will do is it will just find out what are the basic and expert advices it has to make. Expert advice or decisions it has to give, and it will find out who are the end users. So then many times when I'm talking about this, when and I'm talking about this particular expert systems, I will talk about domain experts, and knowledge experts. Sometimes the domain experts can be a system, sometimes domain expert can be a person also, because human expertise is needed for developing these expert systems. Sometimes this domain expertise, you will call people and find out info- expertise, and you also have systems with domain expertise, like IBM, Watson, and so on. So it identify, see, the first phase is called as identification phase, where it determines what type of expert decisions are to be made, what are the end, who are the end users. Then it will find out what are the important features of the problem. Something like that. So what are the requirements? What are the features of the problem? And then what are the what type of requirements that you got from domain expert in the terms of person as well as system? And then what is expected? What is expected outcome of this particular subject? And then these features at some point of time we call, whenever you are doing a project, we call it as objectives at some point of time. And when mycin was made, the initial objective was to identify the disease attributed to the symptoms. Then slowly what they have done is they have added many objectives and features for that mycin. Now the latest version of mycin can find whether the person is prone to COVID or not based on the access that are submitted to the system. So the next phase is called as conceptualization phase. Which is also very important in the terms of designing an expert system, where it is like some ER diagram where you are trying to find the relation between your the data that you have, relations what are there, which are very vital. Relations in the terms of whenever people are talking about expert system, the textbooks that you have, 5 or 6 textbooks, they talk only about the mycin expert systems. So, what type of symptoms are chronic? What is the outcome of this particular action will be the input of some other action? What type of relations are there? Like if I'm suffering with uh, headache and temperature, there is a probability that you will have fever. And then every chance getting a fever, you will have a different type of symptoms. So how do you find the relation between all this data that we have? And it will also find out what are the control mechanisms, what type of algorithms you are using, control mechanisms you are using. So what type of algorithms that are needed to find out, like problem solving techniques that we need to identify. And then this is what is very important. Whenever people are talking about control experts, they are talking about this knowledge engineers or knowledge experts, because knowledge experts will be people who are going to implement this. You can have many domain experts, but initially when people are developing this knowledge expert will be a team that they generate these particular expert systems. So expert system properties are different from a normal system. And in the first initial phase, they will find out how many end users are there. Based on that, the societal significance will be calculated. And what are the objectives of the system? What are the features of the system? And they will find out who are the domain experts in that particular area. And in conceptualization phase, you just try to find out what are the relations which are vital to take some decisions. What are the control mechanisms in the terms of algorithm that we need to develop? And you need to find out who are the knowledge experts who will be implementing this. And it will also tell about the scalability of the project, like granularity, how many people are involved, and what is the level at which the knowledge is stored, and so on and so forth. So the third phase is a very simple phase. We call it as the formalization phase. The third phase is very simple, but it is vital. So what it will do is it will just find out whether you have any tools which are already available in market to implement, because you have almost 5 different phases. Each different phase you will have set of tools that are available in the market with respect to the domain that you are operating. It will find out whether you have any tools and what type of data structures that we are using to store the data. You're using to store the data. And then they will also find out whether you're using, now people are using Python, earlier people are using Fortran, people are using Prolog, or people are using Lisp, and so on and so forth. What type of language that you wish to use for implementing your expert system, and so on and so forth. And what is the inferencing mechanism? Like inferencing mechanism, you can have a rule-based system or something like that. Most important in formalization phase, I'll finalize what type of tools, because you have acid, arid, additive. We have many tools that are available in market. We have almost 758 or 756 tools that are available for designing an expert system in various domains. So what type of data structure is used and what type of language is used? Used a root-based system or a rule-based system or a forward chaining or backward chaining? What type of mechanism is used for getting the inferences? So as per the implementation is concerned, the formation play a vital role in decreasing the implementation role, because if it has almost 3 or 4 tools that are already available in the market, obviously the implementation phase will not take more than 8 months, even in expert system. In expert system, to design an expert system, it will average time to design an expert system in health informatics is 2.6 years. So you have other phase, very simple phase called as implementation phase. Which is a very simple phase like what you see in software engineering. So whatever knowledge representation that you have in this formalization phase, this is knowledge representation. That knowledge representation will be converted into time in the terms of program here to make some inferences. Slowly, implementation phase will rotate in incrementally, so that until unless you will get some first phase output, or we call it as a prototype at some point of time. Or first phase output, second phase output, third phase output, a third increment, fourth increment, so on and so forth, until and unless at least if the objectives are 10, at least we need to have a prototype that can be displayed, alpha prototype for at least 5 objectives are met. We can have this first prototype that can be released. And the testing phase that you have for expert system is very difficult phase because uh, a testing phase, even though you have various testing techniques for export system, because it is a domain specific. See, mycin is an export system used by many doctors to prescribe medicines. Initial conclusions of this particular cancers pertain to breast cancer, bone cancer, and lung cancer. They are doing it with mycin itself. So, in testing phase, the human experts also has to test the system. Apart from the general testing strategies that we have, it's very difficult testing process because the testing process itself is the most prolonging phase for this expert system. If the expert system is designed within 1.6 years, almost the same time it will consume to test that software in health informatics, because the entire textbook that you have, whether it is a Richard Knight course or the Suraj Arvind or whatever textbooks that you're reading, Rose or so on and so forth. All these textbooks, they when they design an expert system, the intention behind that is mycin. When people try to have this conceptual dependency scripts and so on and so forth, the intention that they have in their mind is based on the robotic design. A robot, how do you design a robot? So, a testing phase, whenever you need to test a system, you need to have your own parameters to measure your efficiencies. And now, how many people are there to ratify the outcomes? And how do you evaluate the prototypes? When you take the necessary feedback for the maintenance phase that you have. So it's very easy to remember all these phases because you have already done this in software engineering. Identification phase, where you identify the scalability of the project in the terms of societal benefit, identify the futures, objectives, and knowledge experts will be using. Conceptualization phase, where you are trying to find out the relations that you do in AR diagram and what are the programming skills like control mechanisms or algorithms that you use, and how many knowledge experts are needed, what type of expertise is needed. So knowledge expertise means you need to implement and you need to get inferences. And domain experts means it can be a person, it can be a system, and they have knowledge on the domain. So obviously it is not a single domain expert that will be helpful in expert systems. At least the domain experts for each expert system will be more than 126. That's what your textbook says. So formalization phase, it's almost prior implementation. You will find the tools, it will find the languages, it will find the place where you store, whether it is in a cloud or grid at a cluster, and what type of inferencing mechanism we are going to use. In the implementation phase, they will talk about various prototypes, like now what is the first phase outcome, what is the second phase outcome, how do you generate a better program which can infer something. So many times they will ask you this question when people ask you about this expert system. Then we need to see the architecture of an expert system is very important, because most of the people are concerned about the architecture of an expert system. So when we talk about a design of an expert system and an architecture of an expert system, can somebody tell me how many types of knowledge are there in an expert system in artificial intelligence? Is every time the knowledge is static? Like Rama is a boy is true every time. In database, how many types of statements are there? Is there any possibility that you have a rain at 5 o'clock at Hyderabad? Is a statement that can be predicted at some point of time. If I say the probability of getting a rain at Hyderabad is 0.2, which can be validated only after 5 o'clock, whether it is true or false. So if my statement that you have rain at Hyderabad at 5 o'clock today is true, then the belief system that we generate will be more. So you will have a value that is added to that certainty factor. So the statement belief on the usability of the system will be more. So every expert system mostly will have domains based knowledge systems. We call it as this is a knowledge system. But you need to understand when you're talking about knowledge of an expert systems, it is how do you make conclusions with incomplete data? When the entire data was there in your hand, you can take some inferences, but even though some of the data is not available, also you need to take some decision. That is, so how many types of database are there? Like how many types of database systems are there in your expert systems? Can somebody just tell me? If you remember when we were talking about weather prediction, also I said you have different type of parameters. One is static, other one is dynamic. So your knowledge database must have how many types of data that you have? You need to have how many types of data? You will have static data where the data is valid around the clock. What is the other one? The problem when we are taking classes and online. What is the other data that we have? So in the morning we have good number, but now we have only poor. Then we have to cancel the evening class. Then you have to read on your own. That is very better. This is very bad. Like staying here and not answering a query is not accepted. So you have a static database. You also will have a dynamic database where the statements values will change with respect to time. So the main important component of an expert system is dynamic knowledge or dynamic database. You also have a static database. Sure, you are aware of this. And user every time user will interact with an expert system. So user interface will be there, where the user will ask many queries, and it tries to have a connection between this knowledge database, and you will get try to have this. But in the user database, you have the output of the entire design system will be explanation module. Based on the output of the explanation module, only people will be using this expert system, because I say the probability that you are prone to have bone cancer after 1 year, if I say it is 30%, you need to give a lot of explanation and why, how this conclusion was made. So if the conclusion is have graphs or analysis on events, then only people will try to believe and usability of the expert system will be there. So the outcome, whatever diagram that I have drawn, what is the output of an expert system is? The output of expert system is an explanation module where you're giving the reason that you have made to that conclusion, why we have, why you have taken the decision. Like even in most of the mycin cases, people will not, they are not using it for COVID, but they are using it for cancer, whether it is a breast cancer and so on and so forth. So when you say that, if you see the average output of a mycin for a patient who can have um, protein coding region, or who can have a basic cancer version after 10 years, the minimum output will be around 365 pages. They give the decision and they will give the supplementary data why this decision was taken in the terms of graphs, in the terms of use cases, in the terms a lot of documentation they give for the patient to read and just validate that. And all this data that you give, all this decision supplements that you give, all the analysis that you give, all the use cases that you give will make the user to rely on your system. This is how the decisions are made and so on and so forth. So if somebody asks me what is the starting point of an expert system, that is user interface. This is the starting point. What is the ending point is explanation module. And the most important module is a knowledge base, because the static database will be keep on updating and this dynamic database will be keeping on updating. And then the most important phase that an expert system will has is a knowledge acquisition phase, which is vital. So if you see the tools that we have in expert systems, most of them will be knowledge acquisition tools. So what is the difference between two expert systems? If somebody asks me, you have a program like if you design an app, you have various parameters to measure the efficiency of the app, how many people are using, what is the app that is in demand, how many people are using at this moment, how many people will stand by using the app for time, so on and so forth. Like if you design the expert system in the same domain, most of the time this knowledge acquisition module will be the difference between one expert system and another expert system, because the knowledge acquisition is can be done from systems, and it can be also done from human beings also. So the second part is very important. That second part will be the part which will be helpful to use the system locally, to localize the people. So every time knowledge acquisition will be taken and you will have a connection between these two, because knowledge database will be updated only because of this knowledge acquisition module. In the earlier slides, I said when you design an expert systems, you have to talk about knowledge acquisition, expert or knowledge experts. You also have domain experts and so on. So domain experts are in general will be the experts who are designing the system. Knowledge experts are experts who are we can call it as a system as a knowledge expert, or you can also have human beings. In my scene, the doctors are knowledge experts. In my scene, the practitioners are human experts. In my scene, we call statisticians as human experts and so on and so forth. So among all the modules that we have in this four modules that I have written, knowledge acquisition module is the most important module for the more usability of the system. And but every expert system, if you ask what is the outcome, practical output of AI, you say it is prediction. The prediction happens because of this inference mechanism. Inference is vital, and inference mechanism, as you see, as you have seen in first unit, like inference mechanism will have you try to have an inference, and you have a control mechanism for this inference also. The same thing I am writing. But what is important is an expert system has to make some inferences based on the data that is available. Again, that you will have a coordination between the inference engine and knowledge engine, because most of the time, if you wish to make an inference, it has to no, it has to supplement and it has to get the knowledge data from this knowledge engine, and then only it has to validate. One of the outcome of expert system is an inference, and it is a partial inference and so on and so forth. So inference and control mechanism that you have seen in the first unit and keeping it here. And we have when I say inference, as far as this particular point is concerned, the inference is an inference which is 100% true. You have other inference mechanism called as a special inference. The special inference is an inference where you need to think it as an inference based on the data that is available. And this inference, uh, every statement will have a certainty factor, that value will increase or decrease. So you cannot say that the inference that you got from special interface is every time correct. So every statement pertaining to this special inference will have some certainty factor. Certainty factor, like inference, when I say inference engine, as far as this part is considered, the meaning is the inferences that you take are 100% acceptable. And special inferences are interfaces are this is an interface where we try to process data which is uncertain. See, I have a statement in a database saying that definitely at 5 o'clock there is a rain at Bembaram. That is not valid because it will have a certainty factor. So you have a special inference, you have a special interfaces, and most of the time, when 6 patients are suffering with fever, all the 6 patients may have different types of symptoms and different types of analyzing mechanisms that they will be adopted by the doctors. So one patient they will go for blood test. Some other patient he will give some medicine. Some other patients he will ask you to go for urine test and so on and so forth. So every knowledge acquisition module or every knowledge acquisition that we have, it depends upon the case history that you study. A case history is the most important module because if you study the history of a particular patient, we'll find out what type of diseases that he's prone in future. So obviously, case history will help you to make a better inferences that you can have. So all these are very important in the modules that I have written. Just I will get that. The module in the modules that I have written, the most important module is knowledge acquisition module because this will be the difference between two expert systems. And this is the first module of the expert system. This is the first module. This is the outcome of the expert system. Like you give the explanation in the terms of why we have come to that conclusions. Inference mechanism is a vital part of an expert system. That is the reason this was there. Special interface are the systems where they try to process the data which is uncertain. Case history is vital because without case history you cannot process, because based on this only the predictions will happen. When we try to process the people who are having cancer, the case history becomes vital. Is there any hereditary? What type of food they will consume? So on so forth. Many other constraints are there. So case history, based on the case history, the knowledge acquisition values will change. So this is also a vital part in this. So if somebody asks me the design of an expert system or architecture of an expert system, this is how we have to draw. So I started drawing the diagram from this place because without knowledge, without data, you cannot have expert systems. So this is the starting point I have drawn. Then I have given
Sir,
this.
excuse me, sir.
Please.
Sir, we could not see your screen, sir.
No, this is what you have to tell before. Sir, I will come.
Right now you told that from here we'll start, sir, so we could not see your screen, sir.
From the starting hours, from now itself.
From the starting, sir, but all the theory, the audio is audible, sir. All that you have said about myself, that is clear, sir. But from where you started that we'll start this guide one, we could not see your screen, sir. And from the starting, your screen is not shared, sir.
Yeah, then you can tell it before, Hada. That is the problem in online classes. Did you see this slide earlier? No. Is it right?
No, sir. This is the
The
first
slide
time that we
you
got
are
your
seeing.
screen, sir.
Well, then you have to tell about it. This slide also you have not seen.
From the starting, we have not seen any of the slides, sir. The screen is not shared, sir.
But then you can tell that it was started at 4 o'clock. Anyway, there's no problem. So what is that we do is we'll do it again. See, what is that? The agenda of this class is very simple. Like, what are various export systems? And if somebody wish to design an expert system, you need to have the standard phases are there. We have 5 phases of an expert system, which are very important. And many times people will ask you about what are the various phases in expert systems and explain the design of an expert system. And they will ask you what are the tools to build these expert systems and so on and so forth. These three are very important in the terms of an expert system. And they will ask you what is a truth maintenance system. The truth maintenance system is a system where you add some facts. Does the conclusion will change or not? And you have a blackboard system. And you have a rule-based system. And so on and so forth. So truth-based systems are systems. You have two types of truth-based systems where you infer something, that inference will be valid throughout the later date. You have some you have systems where the inference can change with respect to the new data that is valid added. And blackboard systems are systems. These are not systems actually. These are the environments to create these expert systems. Because whenever you wish to create an expert system, you have a lot of people like knowledge sources will be there. You create an expert system in MySim. You need to have doctors, you need to have practitioners, you need to have statisticians, you need to have domain experts, and so on and so forth. All the experts you need to have at a place, and then you need to have what is that we call control strategy. Then you need to have a blackboard. Blackboard is an environment where we can design an expert systems. And rule-based systems are systems when we need to write like water jug problems are there. Water jug system is there. We call it as a rule-based system where you start from the goal, or what is that we can call in rule-based systems. You can have a data that is like this. You need to have a production and you represent the production like this. You start from the starting state and reach the goal, or you can start from the goal and reach the starting point. You can go for forward chaining or backward chaining. So whenever people ask rule-based systems, you can write this water jet problem and so on and so forth. So what is that we do now is we'll talk about various phases of an expert system. Then we go to the architecture of an expert system. So phases are very important, but the phases will be many of them will be similar to the normal phases that we have in software engineering, but an expert system is different from an ordinary system because the societal significance will be there for the expert system. And the expert system will also be operated only in certain domains, not in every domain. When people think about Cytel, it only talk about the stock market. When people talk about Mycin, it will only talk about health informatics and so on and so forth. So the knowledge representation for an expert system is different. The expert advice that they give is different, and there is a difference between an expert system will have its own advantages and disadvantages because the expert systems will take consume more time to develop, and it will take more time to validate also the expert system and so on and so forth. So the first phase in general in an expert system will be identification phase, where you try to identify the objectives of the system. And once you try to have the objectives, then you try to find out who are the human domain experts that are there. Because whenever we are talking about expert systems, we have to talk about two people: domain experts in the terms of human beings, domain experts in the terms of systems. And we need to talk about knowledge experts, where they try to implement your project. They understand, they use the inferences and so on and so forth. So once the goals, objectives are clear in the first phase, then we will find out who are the end users, what type of expert advice it has to give, and what is the validity of this expert advice, and so on and so forth. So identification phase is a very simple phase where you will just try to find out who will be using that particular part and what type of input that you are getting from the user in the terms of on how many human domain experts are available and what are the objects that are clear. And then if you have human expertise, not only the domain expert in the system, you will also find out. And the next phase that I said is conceptualization phase. Very simple phase where we'll be talking about like how do you find the relations and what is the role of the domain expert and knowledge expert. And then how many people are there? Like, see, you need to find out the cardinality or granularity of the particular place. And then most importantly, what is the problem solving technique that was used, and so on and so forth. This is what I said in the earlier slide. So the identification phase, I said we need to identify the expert decision, then how many end users are there, what are the features of the problem. Conceptualization phase, you just try to find the relation between your data and how many people are there, how many knowledge experts will be available, how many domain experts are available. The problem solving technique we need to identify, and then we can proceed. This is what I have written here also, the same thing. So the third phase is a formalization phase, which is very important. What type of tools are available here? Formalization phase, where we talk about what tools are already available and what are the data structures that you are using for storing the data. And the entire framework, like what type of algorithms you use, what are the control strategies, mostly what type of language that you are going to use, whether it is a Lisp or Prolog or Car or Cadre or Algol or a Prolog or Fortran, what type of language that you are using to design this expert system. Then I said you'll have an implementation phase. So the implementation phase is a very simple phase where we need to convert the knowledge in the terms of a program. And how do you get these prototypes or incremental outcome every time and validate that? So as per the expert system design is concerned, if half of the objectives are released, so you can release the alpha version of the prototype. Then the testing phase is very difficult part of an expert system, which will consume more time. Because this testing phase, people need to validate this testing and system. We need to have different procedures to validate the system and so on and so forth. And you need to have a phase where you can add new modules to the expert system. The testing phase is a very difficult system phase where because most of the testing phase, the expert systems have failed. If you see if you read the textbook also, you can understand. After designing an expert system for 2 to 6 years, many testing phases have took almost 3 to 6 years again to validate that system. And that is one of the reason most of the people are not interested to design an expert system in this particular health informatics. So testing phase, try to evaluate your systems in the terms of various parameters that you have, that we need to create our own parameters. That's what I said earlier also. So identification phase, formalization phase, I said you need to have the tools in the market which are available. What are the data structures? What type of language? Is it a Python or Fortran or Lisp or Prolog language that you use? What type of inference mechanisms, whether it is a forward inference or a backward inference, whether you wish to move from starting state to the final state or from the final state to the starting state, that is goal to start or start a goal. And implementation phase, you need to have the proper inference mechanism which will convert your knowledge into the types of program. And first phase implementation, prototype, and so on and so forth. I said testing phase is a very difficult phase and it is a more time consuming phase among all the other phases because many people has to validate this. This is what we have discussed about the phases of an expert system. Then we have to talk about the design of an expert system in the terms of architecture. Design in the terms of architecture. In the design of an expert system, the entire expert system or entire machine learning, the entire machine learning without data, there is no existence of any of the algorithm. So you need to have a database. This database will have static database where the statements is true and all these are facts. You also have a dynamic database where the statements values will change with respect to time, or every statement will have a certainty factor. The certainty factor will increase or decrease with respect to time. So uh, a knowledge database or knowledge base is vital for taking some decision in expert system. That is what I said in the last slides. Then every expert system will have an interface where in this interface particularly user will interact, and this interface also will interact with knowledge database, and they will give some conclusions, and these conclusions we call it as the explanation phase. Explanation phase is a phase which is vital for the end users. If somebody wish to rely on what decision that you have taken in the terms of expert systems or what type of expert advice that you have given, this explanation module is vital. That is now just prior coming to the class, I have seen what type of explanations they are giving it for a small simple cancer. They are giving 576 different documents or 576 pages of documentation on why this conclusion was made. So the input, they take from this user control is this user interface. We call it as this user interface. User interface, and the output is an explanation phase where you give the analysis or expert advice, and you will also give a lot of graphs here where this decision was taken, and you give also the use cases. You give also the analysis why you have concluded this, something like that, which is very important. If somebody wish to use your system, you need to give more explanation and documentation. Without your explanation and documentation, people will not be relying, even though your decision is right or wrong. So at this moment, I feel this knowledge database is important, but you have a component of expert system called as a knowledge acquisition, which is very important. Knowledge acquisition is a phase. Knowledge acquisition is a module where you will have many tools. Knowledge acquisition can be done by using C language, by using Prolog. Many other tools are there. Art, automatic reasoning theory. Many for this phase. So, if you wish to ask me what is the difference between two expert systems, if this phase will be the phase which differs your expert system from other expert systems. You can have knowledge acquisition from human beings, or you can have knowledge acquisition from also from your systems also. So, among any of the modules that I have drawn or I am going to draw, the knowledge acquisition phase is the most important phase in the expert system, because all the data that we acquired for the expert system will come from this knowledge acquisition module. If the usability of the expert system has to be more, it has to be the explanation phase, which has to be vital. Then we have seen the first unit, you have drawn a diagram of AI, what are the components of AI. Every component will think about inference. Inference module will be there. You have a control module which has to become first. So the inference engine or inference module that I have drawn here will take decisions which are 100% valid. All these are facts. You have a special interfaces which will deal with uncertain data. This is inference and this is interface. Special interfaces are interfaces where uncertain data is processed, and every statement will have a certain validity and certainty factor that was augmented to it. So these are the components. Apart from this, we'll also have a case history or case study. In some textbooks, it is case history. Some textbooks, it is case study. You can write anything, but casing is important, because based on the casing history, only certain decisions will change. That's what I said earlier also. Like 6 students are suffering with fever, and the analysis that the doctor needs will change with respect to the history of diseases that this girl may be attributing. So casing case history is the vital part of your expert system also. So in all these parts that I have written, I'm just try to highlight this part. So this knowledge acquisition is the most important module in an expert system. This explanation module is the second important, because the explanation module will be the difference between two uh, uh, systems in the terms of usability. In the terms of adaptability, usability, and implementation, this will be the change. An inference engine is an engine that you are going to infer something with known data. Special interfaces, they process only incomplete. How do you take decisions from an incomplete data? With, if case history is an optional module in expert systems, a knowledge database, without this database, there is no existence of machine learning. That's what we said earlier. I said earlier also. In this earlier slide also, the same thing I have written. When you design an expert system, the expert system will start with user interface and end with explanation module. And most of the expert systems will rely on the knowledge database. So knowledge database is consists of facts, that is called a static database, which are not facts, but that may be valid with respect to time. We call it as a dynamic database. And you also have a very important module called as knowledge acquisition from humans or systems, which plays a vital role. And that will be difference between two expert systems in the terms of design. Case history, case history, if it is there, the conclusion will be more optimal and reliable. The special inferences or special interfaces are interfaces where they process data which is uncertain, which is not complete to make some certain decisions. That is what I said earlier. And now if I see the agenda of the class that I have kept here. So I said expert systems are, we need to discuss about the 5 phases. We have discussed the design of an expert system and architecture of expert system is very important because all these modules are freely available. Then we need to think about some set of tools which are available to design an expert system, which are all automatically available in our market, so that you can use this automatically whenever some expert systems in Mycin are used. We use this ARQ like tools to design an expert system, which is very important. Many people will ask you this query. Tools to design an expert system. So many of the tools will be based on the language that they use. Many of the tools will be based on the knowledge acquisition, because most of the tools they will give the knowledge acquisition phases to you. And you have some companies like if you see Prolog itself is a tool to design an expert system. That is what we have learned in when we are doing some BTech. So I will write the names of tools that are already available. Then based on that, we'll have a discussion if it is needed. See, if I need to have a knowledge acquisition phase, which was written here, I need to have this phase. Then I have a tool called as acquire. Acquire is a tool which is meant for knowledge acquisition from both a human expert as well as the system. We can use this in the terms of Unix as well as Windows. That is what this tool advantage is. So I said in this expert system design, knowledge acquisition is vital. Knowledge acquisition, we have almost 76 tools that you can use them, plug and play a type of systems are there. So the acquire is that kind of system where we can use both this particular tool in both operating systems. That is Unix. Most of the people will use, almost 60% of people use this Unix, and rest of the people may use Windows. In this both conditions, there will be that. And then if you wish to have, you have a phase called as special inference, which will talk about the uncertain data. You have a tool called as RET. RET itself is the name of the company, where if you wish to develop an expert systems which has certainty factors. Certainty factor means your data is incomplete, so every statement will have a certainty factor. So if you wish to develop an expert systems at real time, where the values will change with respect to time, you can use this tool. RT is for fuzzy systems, like fuzzy expert systems, where the data is consists of certainty factors. So if you see the design of expert system, I said explanation module is very important. Explanation module is a module which will make a difference in the terms of user satisfaction, and user will certainly rely on your particular expert advice, and he will also believe also. For that, you have a tool called as ART, Automatic Reasoning Tool. ART is called as automatic. RET itself is the name of the company. They're developing various tools, automatic reasoning tool, which will tell you why this conclusion was taken by this expert system. And I said you can implement expert systems also in C language. We also have clips in expert systems where this is a production system. PS means this is a production systems. Production systems means in Prolog, I write a production like this that is valid and duly recognized. C language integrated or I don't know, but C language, this is CL means C language, and this is integrated production system. If you wish to design a rule-based system in C language, you can use this clips. So what are the things that we have discussed is acquire is used for knowledge acquisition. And if you are trying to use this special inference or interface, then you can go for RT. RT itself is the name of the company that designs fuzzy logic systems. So explanation module, if you used to have more explanation for what the decision was taken, in automatic reasoning tool was there. If somebody wished to develop a production system or a rule-based system in C language, we can use clips. C language integrated production system. And I said Prolog itself is an expert system tool. So you have a flex system or a flex tool for developing an expert systems, which is an amalgamation like you have a cell automata, you have a deep learning, you augment both of them. You will call it as a hybrid data type or hybrid structure. If you wish to have this hybrid structure, you wish to see, I have 3 or 4 grids. We call it as a cluster. That cluster can have its highest processing power. We call this as that type of systems. We call it as hybrid systems. When you wish to develop an hybrid systems in Prolog, we can use this flex. Because if you see the domain of IBM Watson, IBM Watson will also operates on the domain of MySIP. So if you see the second layer of IBM Watson, it is an amalgamation of IBM Watson and the Mycin in the second layer. So if somebody wish to develop an hybrid systems in Prolog, we can use this flex. And I said you have truth maintenance systems which will use forward chaining plus backward chaining. Forward chaining means you start from starting state to goal state. Backward chaining means you start from goal state to reach the starting state. Both the ambitions are same. So that type of rule-based systems, if you wish to implement, we can use this Guru. What is common in this Guru is Guru and Arity are fuzzy systems. These are fuzzy systems which operate on unreliable data and data which is not complete. Likewise, you can have many things like I wish to visualize the outcome. Like I have an explanation module where I need to visualize this. I can have KVision. KVision will give output in the terms of charts and graphs so that you can understand the analysis very easily. And you have other tools called as Mailbot, where you can have a bot for automatical response for the mail and so on and so forth. And Mycin is there. T-Mycin is meant for kids. All these can be called as tools to design and expert systems. Mostly TK-Vision, we can call it as expert system tools. So we have various tools of an expert systems like Acquired is a tool which is pertaining to the knowledge acquisition module. RET is a tool which will facilitate this special interface. Art is meant for understanding understand the outcome of the system. So you can have art clips. If somebody wish to develop a expert system in C language, I can use clips. Flex is a hybrid system which can be developed in Prolog. Most of the expert systems now they use this Flex module. Guru as well as this RET, they are fuzzy systems which use both rule-based systems. And other things that I have written are very simple things, K-Vision and Mailbot and T-Vision. K-Vision is for visualizing your outcome. And T-Mycin is meant for kids, it seems to me, and so on and so forth. So all these tools, 1, 2, 3 are very important. K-Vision is also important. Clips, Flex, and Guru. These are the tools that are already available to implement this expert system. This is what the partial result of the class is. The rest of the part is very simple. So expert systems, design of the expert systems tools, then we can think about what is a blackboard system or not. What blackboard system is a simple concept, but most of the people are aware of that. See, blackboard system is an environment blackboard system is an environment where which was created to design an expert system because you have various knowledge source one, you have various knowledge source two, knowledge expert three, knowledge expert two, and so on and so forth. Because most of the expert systems, you need to have variety of knowledge experts, and then you need to have a control, which is first and which is second. Like when you're designing Mycin, you have various knowledge experts called as practitioners. You need to have doctors. You need to have statisticians. Many other people who can validate, biochemists, bioinformatics scientists, and so on and so forth. All these are knowledge sources. So when we try to design an expert system, there is an environment to create that expert system. If you remember in the morning class, I said you have something called a CYC. We call it as common sense database. You wish to create a common sense database, you need to use CYCL, is a common sense language that you can have. So that language that is developed, or if you wish to develop a common sense database, we have to use this Blackboard mechanism. So what are the three components of Blackboard is Blackboard itself is the first component, and you have a control mechanism. The third one is knowledge source. These are the three components of Blackboard systems. A Blackboard itself is an environment where we can interact and we can try to provide solutions for these expert problems. To interact, you need to have control because who is the first one, who is the second one, these people have to decide. And there are many knowledge experts who are part of initial design, even in the implementation part, even in the testing part also. So most of the people, if you read the textbook, you can understand that Blackboard is one of the mechanism or the environment where you can create expert systems which operate at large scale. This is about a Blackboard system. A rule-based system means you need to write about what is forward chaining, what is backward chaining, and then you need to explain, write the water jug problem, and how do you represent knowledge in this water jug problem. So when people try to ask you about a rule-based system, you have to write about this water jug problem. You take some problem and explain how do you create knowledge, and then you need to write how do you move from one state to other state by using this knowledge? Then you can write the strategy that you have followed is called as forward chaining, because you're starting from starting state and reaching the goal state. And there is every chance in AI that you start from goal and reach also starting state. We call it as backward chaining. So this part, because we have done this in first unit, there is no need that you have to discuss it again. And the simple part that is kept pending is very simple, is called as truth maintenance system, which is very easy that you can understand. Theory you can easily understand, you can write it. Truth maintenance system, there are two types of truth maintenance systems. We call it as monotonic, and the other one is non-monotonic. So how do you maintain the stability of database irrespective of whatever inferences that you take? So in monotonic, like Rama is a boy. He is born in 1850. There is a volcano in 1900, and every one has died. So what is the conclusion that we can make is Rama is also no more, Rama is also died, is the conclusion that we can make from the statements. So whatever data that you add to the system, this inference will not change. So there is no instability that can be attributed to this type of monotonic system, because you try to infer, you add some other values like Rama is a student, Rama's father is somebody. You add some values, that inference that you took, it will not change. The inference that you made from the statements will not affect, or the inference is valid and this is 100% right. Whatever statement that you add later will not have any significance, or it will not, whatever statement that you add, this inference will not change. But if you take a non-monotonic system, assume that I take a statement called as birds fly. Ostrich cannot fly. And sweetie is a bird. So what is the inference that you can make from these three statements? Birds can fly, ostrich cannot fly. Sweetie is a bird. So what is the inference that you can get from this particular statements? Does this sweetie can fly? Birds can fly, ostrich cannot fly. Sweetie is a bird. Does the sweetie can fly?
Sir.
Yes, sweetie. You said it is yes. So I said a truth maintenance system, you have two types. Monotonic system, you take a conclusion and the conclusion is valid around the clock, then you say that it is a monotonic system. If the conclusion will change with respect to time, then I will write something like Sweetie is an ostrich. Is an ostrich. Now, does Sweetie can fly?
No, sir.
No. So
No, sir.
adding these new statements will invalidate this conclusion. Then we call it as a non-monotonic system. So when people talk about truth maintenance system, you have to write about what is a monotonic system and what is a non-monotonic system, and then you can explain a little bit. Then that will be useful. Is that I said about an export system phases, design, the tools, and then we spoke about what is this a truth maintenance system, blackboard system, and rule-based system. So we'll go through the question bank if it is there. It is there. Okay. So fourth student is fifth student. What are the components of an expert systems? You can write about formalization phase, conceptualization phase, identification phase, and implementation phase and testing phase. And whenever people talk about expert systems, we need to clearly say about knowledge database and human experts, knowledge experts, and domain experts. And what is a truth maintenance system? How does truth? So you can write about a truth maintenance system. I have two types, monotonic and non-monotonic. And what are the advantages and disadvantages of an expert system? How does this blackboard system will be helping for problem solving? Right. Compare and contrast. Rule-based system means you have to write about this water check problem. Blackboard system means you have to write about the blackboard and the knowledge experts on the control that you have. Rule-based systems means you have to write about that. Various tools means you have to write about this RT and you have to write about this flex, guru, and so on and so forth. Clips and so on and so forth. What are the important phases of expert systems you can write? What are the various applications of expert systems you can write about about Mycin or any of the weather prediction system or any of the stock market prediction system in detail or elaborately, whatever it may be. Significance of blackboard systems we have discussed. Compare and contrast general expert system and blackboard expert system. Then you can write about here Mycin and a general blackboard system architecture that you can think about and discuss various phases involved in designing an expert system. This is what I have discussed. So obviously there is no big problem for answering this queries. So what is that I do is instead of taking a class at 9 o'clock, I will take a class in the morning at 8 o'clock. That will be better. 8 o'clock people are coming. And if this is the attendance, there is no need that we have to take a class even for this last unit. What is that I do is I will take a class in the morning at 8 o'clock tomorrow for completing the sixth unit.